Welcome to Spitfire Mods. This video is our video titled Different Board Types, Different Profiles. And what we're going to do is we're just going to speak for a couple minutes about different boards and how to accompany those boards. Let's say you have your rework station set up, you have a PS3 board on there, your profile looks great, you're getting a nice plateau in the 160 range where your flux needs to be, you're soaking the flux good, you're reflowing perfectly, you're getting your component up to 220 something, you know, melding your unleaded solder, and you got great reflows with the PS3. Let's say then you take your PS3 off, you put your Xbox board on there and you're probing it, and your Xboxes are getting damaged, they're burning up the boards. This is where it comes into play that different board densities and different board types have different profiles. And what you're going to find is the difference between PS3 and Xbox is roughly 15 to 20 degrees Celsius. So if you have a PS3 profile and you want to now learn how to do Xboxes, most likely you're just going to chop about 10 to 15 degrees off your profile, and that'll run to the right temperature on an Xbox, and vice versa. Let's say you did your Xbox, say you calibrated your machine with your Xbox board in there, and now you want to switch to PS3s, you can pretty much bump all the numbers in your profile up about 10 to 15 degrees, and you'll get a good PS3 temperature. You'll probably hit 221 right at the end of the profile as well. So keep in mind that different board types, different Xbox and PS3s, an Xbox board is very thin, an Xbox board warps a lot, warps very easily. If you look at a PS3 board, it has very large copper ground planes. These copper ground planes go all around the edge of the board and they reinforce the board. This board also has a ground plane across the entire board itself. The Xbox board has that same thing, but it's much thinner material and much thinner metal plane, so you're not going to see as much warpage in a PS3 board. If you ever heat gun the board, you're going to know that Xbox boards buckle right up like a horseshoe. They'll actually flex like crazy up off the table if you heat gun them too hot, and that's the reason why they warp a lot and they don't need as much heat. So you're not going to need quite as much bottom heat for your preheat, and you're not going to need quite as much heat for your reflow on an Xbox board. And that's basically it. We just wanted to talk briefly about different board types and why you need a different profile. Just so that you do know that one profile may not work across all your boards, and the reason being that their density is different. And the density meaning the thickness of the board, the amount of ground plane and metal material the board has, and the amount of components. You need to know that this board is like a sheet of metal. If you have a sheet of metal and you take a blowtorch and you hold it on the one side, the other side will be cold. Like you can put your finger on the one side of the sheet of metal, but over here it's red hot. And what that is that's what's called, and it's the same thing as a heat sink. It's the heat sinking ability of metal, and that's why heat spreaders and these pieces are metal, and they're metal because they heat sink the heat out. Very thick and dense metal can heat sink a lot of heat, and that's why this metal is a solid wedge of metal. It's almost an eighth or more inch thick. It sits on top of your unit and it pulls the heat right out of the chip into here, and then they put fins off of this metal with your compound to dissipate that heat and get it out of that wedge of metal. And metal is a very quick conductor of heat, so you have to remember that if let's say you didn't have your bottom heater and you're just heating with a blow hot air on the top, you could never reflow a chip by blowing hot air on the top. And the reason being is a chip maximum temperature is about 220 to 240. So if you're blowing hot air on the top of that chip, the amount of heat sink capability of this board is extremely high when not preheated. So you can blow 300 degrees on the top of that chip and that chip won't even liquefy. And the reason it won't liquefy is because the solder balls are below this heat spreader, and they're below this piece of PCB, and then they're down underneath there. And that's a long distance away from that temperature. When you're blowing 300 degrees up here, 300 degrees will hit here, 280 or 260 might hit here, and then if you peel that layer away, down where the solder is, you might be only around 220 or barely there. And that 220 temperature is probably dissipating out into the board so fast that you couldn't even maintain 200 degrees Celsius, and you would never liquefy solder at 200 degrees Celsius, not unleaded solder. So that's why just an upper heater would not work as a reflow station. And again, using an upper heater like that will make your board work almost 100% of the time, even though it's not liquefying the solder, but that's simply because of the warping and the expansion and contraction of the metal causing the crack to come together for a short period of time, and that will make your board work. So the correct statement would be, blowing hot air on the component will make your board work, but it won't repair your board. Repairing your board requires a full liquefaction of the solder under the chip, and that's why your profile needs to have all the phases and have all the proper things in place to get the profile perfect, so that your component, your board is hot enough. Let's say your board's 180 degrees, your hot air on the top is 240 degrees, your chip will reach 220, it will melt, and then you can stop. And that's what you want to do. You want to hit all those temperatures just right. Your board, you don't want it to be a heat sink. You want it to be holding enough heat so that it's not melted and it's not getting damaged, but it's hot enough so that you don't need a lot of difference in temperature, and it won't heat sink your heat out of that chip, so that if you run the component above the melting point, the component will actually fully melt. And that covers our different board types and different profiles. So that's the reason why every board is slightly different, and why you would need a different profile based on density and population of the board. And thank you for watching. This ends our different board types and different profiles video.